My pharmacovigilance people, good to see you. Welcome back to this tutorial. And by the way, for pharmacists out there, what do you call a pharmacist in pharmacovigilance? Do you call them a side effects detective? Anyway, I was just opening up this notebook and I was thinking about, by the way, what do you call a pharmacist in pharmacovigilance? Is it a pharmacovigilant officer or something like that? Or a side effect detective? Just kidding. But anyway, today we are dealing with side effects severity from patient reviews. And in the previous video, I said we'd do this in VS Code. But I realized that that might be very intense for beginners. And especially if I'd want to share the code with you guys, it will be difficult for beginners to have access to GitHub, download the code via GitHub, and then load the environment in VS Code. So in this video, I have just moved everything to Google Colabs. So for those who are not familiar with Google Colabs, so let me just search here, Google Colab. So Google Colab is like an open source kind of space that allows you to handle notebooks for Jupyter notebooks. And the environment gives you access to quite a number of things, space, drive, GPUs. So over there, you can sort of interact with Python code. So let me just see a mod. So definition of Google Colab, it's a free cloud-based service that allows you to write and execute Python code directly in your browser on top of Jupyter notebooks. So we will be using this Google Colab. So that way you won't have to install VS Code and do that kind of stuff. You can just work online. So I will share the link and you can go over the whole notebook or you can follow along. All right. So, okay, my side effects detectives. What do they say? Yeah, my people in PV. Anyway, so over here, our task was for us to think about ways in which we can predict side effects reviews from patients. So we were thinking of how can we come up with this PV project. Okay, so our PV project will be based in machine learning. So if you are new to Python and you're new to health data science or even machine learning, I'd say the greatest take from this video is just for you to understand the intuition, for you to understand the workflow on how we go about things. So the first thing here is we wanted to get some data sets on patient reviews from an online machine learning repository. So we did that in VS Code, but I'll show you how to do it over here in Google Colab. So Google Colab is a space where we can work our Jupyter notebooks, and these are environments where we can run our Python code. So that's number one. Number two, let us just go over this text. So here we will approach it via a machine learning model. We'll build a machine learning model. That's the overall aim of this project. And what we want to do, we want to read patient drug reviews and predict how severe the side effects are using the patient's own words. So previously, we had seen that we can predict, like we can know, we can probably know the extent of the severity of side effects given additional things like patient's age, the dose of the drug, the condition they had, and what have you. But in this case, we just only focus on the patient words, which are, in this case, the side effect reviews, right? So what you learn in this project, you learn how to explore clinical datasets using Python, explore text data using NLP, or what we call natural language processing. So I think an important bit of this tutorial, compared to any other that you may find online, is that our focus will be on text data, a little bit on text data. So for many people who have come across the ML, chances are you've done this using numerical data, which is still okay. But I want to introduce to you this aspect of handling text data because that is where most of the direction of research is going, where you're handling data with AI, with LLMs, okay? So this will be more of you understanding the background of this space, how it looks like, and the kind of problems we are solving using this approach. Okay, then we will compare different models, and then we will interpret the model's performance. All right. Okay, so enough of introduction, and let's go to this bit where we'll be loading the data. So in the previous video, we saw how to download the data, but in this case, because you're working in Google Colab, we will do it a little bit differently. So I have the datasets stored somewhere in my repository in my GitHub repo. So the link is over here. So our dataset is stored in tab separated value, similar to CSV, which is comma separated files, values, but here the data is separated via tabs instead of commas, just from the name. Okay. So now we will begin the session by running this cell. So in notebooks we have these things called cell that allows us to run the code within this section. So the good thing with notebooks is that you can just run code here and it won't affect this at the moment. All right. So when I come to my Jupyter notebook, you can see some couple of things. So I'll just a little bit touch on the UI UX bit of Google Colab before I continue. So you can see there is more functionality that Google Colab gives you. Like for example, if you click on file, you can see how to rename your folder. You can get access to different things. If you want to get access to, let me say, GPUs, you can come to, I think it's runtime, yeah, and change runtime type. So we won't do that for now. Our focus is just on running the cell. So this will just work on normal CPU. So here you can see we have been allocated some RAM and disk. So if I hover around here, you see we have RAM of that is around 12 GB and a disk of 107 GB. That's fine. Okay. So the Python Google computer, it's running, it's operating on this compute. So I cannot do that. Let me just see. It's operating on this compute, in short. But anyway, that's more technical. Right now we're just focused on the data science bit of it, and then if you get time, you can explore Google Colab more. Okay, so the first line of code will just to run this, so that we can pull the dataset. So just press run. So by doing that, the dataset now is loaded within this environment. Okay, so that means you don't have to stress yourself on how to download the dataset. So that is sorted. So next we will go on to use in what we call libraries. So if you have gone through our R tutorial, I mentioned things to do with packages and libraries. So over here, we use pandas library, which allows us to work with tabular data in Python. Okay. So normally you have structured data and unstructured data. So structured data will come in form of tabular data, which makes pandas a very good library for us to use. And then the next line of code, we will create some what we call some variables to handle our data sets or to handle our data frames in this case. So we have two data frames. We have a trained data set and a test data set. So this is important for machine learning because later on, when we are creating our model or when we are making our model, we want to test our model on data it has not seen. So that's why we have these two lines of code to capture different variables, right? Then we will print to see the shape of the dataset, how the dataset looks like. So that's what we will do by running this code. So let us do that. Okay, great. So here we have train test has 3,107 rows with 9 columns. And the test dataset has 1,036 rows and 9 columns. Okay, so we have a picture of what our dataset looks like in terms of the size measurement, right? So next thing in data science is exploring your dataset. So we normally do this via a process we call EDA, exploratory data analysis. So this is normally a very long process. Long in the sense that it gives you time as data scientist or health data scientist or whatever the title is, for you to explore your data, understand your data, and be familiar with what is happening in your data even before you jump into analysis. Okay? This is important because when you come with domain expertise and you understand your data, then it makes it easier to get certain outputs that are relevant to different stakeholders. So in this case, our focus is on pharmacovigilance using side effect reviews. So we want to have a sense of how this dataset looks like. So in this case, we will use this function called .head over here. So you remember we gave our variable, we gave our data frame the variable df.train over here. So we'll do df.train.head to get the first 5 rows of the data frame to see what the data looks like. So when I run that, you can see that here is the data set. It has this number of columns. You said it has 9 columns, so you can see the columns. And then you can see the top 5 rows. So in Python, you normally start by 0. So that's like the first index. So that is like 1, 2, 3, 4, 5. All right. So here's what the data looks like. We have some couple of drugs. We have some columns on rating, effectiveness, side effects, the condition that were used to manage, and the side effects review that maybe the patient mentioned. Okay. To get more information about the dataset or the data frame, we can run this .info function. So when I run that, you see we have more information over here about what the rows have. So the data types of these rows, are there null values, the count of those null values. We get even the size of the data frame. So at least it gives us more information about the data set. All right, so next, let's look at unique values. So let me just press that. So in this case, this is now a good way for you to understand the distribution of what your dataset has. So remember our focus is on side effects, right? So we have side effects categories. So in this case, a side effect can either be, so from this column, let me just scroll back, this column of side effects. The side effects has a range, can be either no side effects reported, can be mild, can be moderate, can be severe, and it can be extreme. So these are like the key values that we are using to rate the side effects review for the patients. All right. So this is what we are trying to understand first. So we are trying to understand that given that we have side effects reviews that have already been labeled, can we learn the pattern, or can this machine learning learn the pattern of whatever review is here? What does it represent on the side effects category? So that's what we will do eventually. But before we get there, we need to understand the distribution of these side effects, because we can't read all of this. I can't give you, it will be very hard for me to give you 1,000 side effects review for you to go in and classify what each means in terms of side effects, but it has already been done in our case. So just to understand the distribution of the data, we see that we have more of the reviews being mild side effects. That's around 1,119, and extreme being 175. Okay. So this is important because this might happen actually in the real world. So whenever you see such distributions, try to correlate with what's happening in the real world. So you can imagine in the case where you have extreme side effects, then you will probably think that there is a problem with some certain, maybe a batch number or some distribution in supply chain or something like that. So this just to keep in mind for you to understand what's happening in the real world is really happening in our dataset. Okay. So the next bit, section 2, we need to select columns that we will use for our task. Over here, we are interested in 3 columns: the side effects review, and the condition maybe. So we'll just add the condition there for now. So we create a data frame, new data frames now that have these columns alone. So we are sort of shrinking the dataset from that wide that wide aspect of like 9 columns to only these 3 columns. So remember, our task here is to classify based on side effect reviews. So we are not putting into consideration the drug, the patient's age, and all that other kind of stuff. So this is like a first step bit to understand this process. So I will continuously iterate over this and this, because I think this is the important bit for health data scientists to understand, or you in pharmacovigilance to understand. You might not be tech savvy or code savvy, and even more often than not, it's AI which will write this code. But you need to be able to understand what the AI needs to take in, or whomever is writing the code, you need to be able to guide them on what variables to include, given the dataset that you have. So we've run that. So next thing, let us handle missing data. So let us see how many missing values are in each column. So when you press that, we see that we have a couple of missing datasets in the training set. So like 75 side effects review are missing. In the test set, we have 23 side effects missing. Okay. So there are a couple of ways of handling missing data. If you also can remember, in our R tutorials, I talked about this, handling missing data. One way is if you can drop that missing data, that missing row, the row that has the missing data. Another way is maybe by imputing with the mean or mode or median. There are various ways of imputing in general, but the most important thing is to understand what kind of dataset you have and if the imputing method makes sense or not. Okay. So in this case, we went about with dropping the rows where the columns were empty. So in each column that, for example, had no side effects, we drop that that row entirely. And the reason is because we have let me say, the dataset that we have is a lot in this context. So for example, dropping 75 out of 3,000 and something rows won't hurt that much for us to just maintain with quality datasets. Okay. So we run this, let us drop that. And now we have a training set of 332 rows and a test set of 113 rows. All right, so that bit we've done with the sort of introduction bit. So next, I want us to move to now encoding and labeling and all that kind of stuff. So for now, I'll just leave the link to this notebook and the description for you to continue with it. And for my faithful viewers, we will continue in the next session.